Now, we can also use stream names as arguments. So from our previous lessons, we are only used with functions in which we provide numeric data types, or shall we say primitive data type variables as argument to our functions. But of course, we can also use stream objects as arguments to our functions. Streams can also be used as argument of functions. The function's formal parameter for the program, however, must be called by reference. If we will recall, we can actually pass arguments to a function in two ways. Remember, we can pass an argument by value, we can pass a parameter by value, and we can also pass a parameter by reference. And of course, if we are going to pass a stream as an argument, of course, that should be a call by reference parameter. To do that, we will have an example in a while. Let's say we have the following function. For example, it is named makeNit, and as you can see here, it requires two formal parameters, which are, of course, both of them are type stream. This one is an input file stream, and the other one is an output file stream. And of course, it is said that when we are going to pass streams as parameters, they must be called by reference. So to do that, we provide the following. We put an ampersand at the end of their declared data type. So that will make them a call by reference parameter. And talking about files, of course, when we are reading files, especially reading files for input, it is important that our program knows when to end or when to stop reading the file. But how does our program know that? Our program knows that by looking for the end of the file. Input files used by a program may vary in length, and programs may not be able to assume the number of items in the file. As a matter of fact, our program does not know how long our input file is. So the point is, it will keep on reading our file, and it actually has no idea how long it is. A way to know the end of the file is reached can be done by the following. So for example, we have the following Boolean expression. We have, for example, inStream is our stream object for our input file. Of course, this variable is linked to our input file, and then it will keep on reading and put whatever information was picked up into this variable next. So this will keep on reading our input file and place it to next until such time that nothing can be read, and therefore next no longer has a value. So that would tell our program that the end of file has been reached, since no input can be seen. So we'll keep on reading a value from inStream and store it into that variable. And it will be true if a value can be read and stored in next. So that will remain true until such time that nothing can be read from our input file. Thus, the end of file has been reached. So here's an example. Let's say we would like to calculate the average of the numbers in a file. So we have the following code. Of course, we declare the following variables, initialize. And of course, what's happening here is that it is assumed that a file has been opened and has been linked into this variable, which is of course an input stream variable. So whatever is the content that can be read from this file will be stored into this variable, and whatever is the content of that variable will be used in the following operation. So what it actually does inside this loop is it keeps on adding whatever value is derived from this variable. Next, then we also update our counter until such time that nothing can be read from in-stream. That's the time that we will go out of this loop and do the following operation. So whatever is the sum of those numbers is, of course, will be divided to the final value of our counter variable, which will give us the average. So for example, let's use this code in a sample program and let's see how it works. Let's say this one. So as you can see here, I recycled our previous code, actually this one. I used this one. So in this case, we will use the same input file. Okay, so what our program will do is, of course, get the average of these numbers from this input file. And this is it. Okay, so that's it. So let's run this program and see what happens. So let's wait for the output, and there it goes. So the average of those number from our input file is 4. So that's it. Next. Let's talk about stream arguments and namespaces. Using directives have been local to a function definitions and examples so far. When parameter type names are in a namespace, a using directive must be outside the function, so C++ will understand the parameter type name such as ifstream. So the easy solution to this is to place the using directive at the beginning of the file. So as you can see in our examples, for let's say this one, all of our include directives are placed in the beginning of the file, such as this one. Okay, because if you're not going to do this, it is also actually possible that a certain function call to a certain library can only be visible within a certain function. But of course, that's not what we would like to do. Because what we would like to do is to make sure that all of the I/O routines, all of the functions that we are calling should be possible anywhere in our program. So therefore, we put all our include directives at the beginning of the file. However, many experts do not approve as this does not allow using multiple namespaces with names in common. But for now, it is the practice that we will follow. So here's another example. So we will show this program in a while. So let's first take a look on what it does. So what it does is it takes an input from row data.dat, then it writes the output to the screen to a file named neat.dat. And of course, formatting instructions are used to create a neater layout, and numbers are written one per line in a field width of 12. Then each number is written with 5 digits after the decimal point, and each number is written with a plus or a minus sign. And we have the following function, the makeNeat function, that has the formal parameters for the input file stream and output file stream. So let's take a look at that example. So we have example 5.6. So again, we have here all our include directives. we include all the libraries that we are going to use. And here's our function declaration, the make init functions. If you will notice, it has the following formal parameters. Take note that two of them were stream objects. As you can see here, they are declared as call by reference parameter, and it was done by putting the ampersand operator in our data type declaration. And of course, we also have the other two formal parameters, which will set our decimal point and the width of our output. So we have the following. We're going to use raw data.dat for our input, and of course, whatever is the content of this input file will be fixed in our final output, which will be written into this file, init.dat. And let's take a look inside our function makeInit. So this is what happens. Of course, our input file will be passed as a formal parameter. Our output file was also passed as a formal parameter. And of course, our decimal point value and width value will also be passed as parameters and used in the following operations for setting the precision. And the other one is for setting the width, such as this one. Now, before we run this example, let's first take a look at our input file. For example, raw data.dat. So as you can see, this is quite a messy file. If you take a look at this, it's actually confusing. So what our program will do is to make this raw data neat and easy to look at. So we will output the following numbers in their corresponding lines, and proper formatting will also be done. So let's try to run this program and see what happens. Okay, let's see. So as you can see here, this is the output of our program, and the same will be written into our output file, which is the init.dat file. So let's take a look. So this is the output of our program written into our output file, which follows the formatting that we specified in our program. So in this section, you were able to use the different formatting tools in C++, which we can use to make our output more readable and of course more appealing to its users. And those are some of the examples. And of course, we can use those tools as well as manipulators in order for us to make a properly formatted output for our program.